Got to get rid of one of them. Which one would be easy to get rid of first? Either put it in the chat or unmute yourself and let me know. Which one should I get rid of first? Okay, we're all shy today, and that's fine. Get rid of the smallest one. So I'm going to subtract P from both sides. Remember, if you have a equal sign and you have a variable on the left and a variable on the right, you got to get rid of one of them. So I like getting rid of the small one because why not? So I'm going to subtract P from both sides, minus P, cross U out. Ooh, this is a lovely problem. Bring down 11. 2P minus a P is a P. My least favorite vegetable. If I wanted to get P all by itself, you could either unmute yourself and put it in the chat. What would I do to both sides? See, we're just going to be super shy today. All the memes about people on Zoom are true. I've been told never to believe the internet, but in this case, I just might have to believe the internet. P equals -7. Baby. Okay. That's problem 1 in our warm-up. Problem 2 in our warm-up. I have to do a property before I can do anything first. That property is the thing on the right side called distributive property. So I'm going to distribute -6 to 1. -6 times 1 is -6. -6 to -x. Negative times a negative is a positive, and 6 times x is 6x. On the left side, I have 6x plus 1. Now, if you think you know what's going to happen, please write it down or please unmute thine self and tell me. But I have a 6x on the left. I also have a 6x on the right. You may remember from yesterday's afternoon class that if I have a variable on the left side of the equal sign, and red means left, and on the right side of the equal sign, and they're the same exact thing, I could just get rid of them by subtracting them out in this case. All my variables disappear, and I'm left with 1 equals -6. Does 1 equal -6? No. So since that's not a true statement, since my variables disappear, and it's not a true statement, it's going to be a no solution. If my variables disappear and I do get a true statement like 1 equals 1, then that's the opposite, which is infinite solutions. But this one is a no solution because my variables disappear. And last time I checked, 1 does not equal -6. No siree. No siree. So, fun fact, this is the last section of chapter 1. Okay? We're going to do a little something called rewriting equations and formulas. Oh, it's SpongeBob. Ravioli, ravioli. Give me the formulae? I don't understand. It's formulae, I know. This is the last section of the chapter. So the next couple days, we're going to be focusing on reviewing chapter 1, which is solving equations of all kinds. This is the last thing that we're going to do. Now, I want you to see all the numbers in this problem that I have. D equals RT. Distance equals rate times time. Okay? I don't see any numbers there. And it's asking me to solve for the red variable, and I don't have any numbers. I guess I can't do it. It's a lie. I can do it. And this is what you do. This is how you do it. First off, is T all by itself? No. On the right side, R is in the way. R is being multiplied to T. So I have to get rid of R by doing the opposite of what it's doing to T. What's R doing to T? Multiplying. How do I get rid of multiplying R? The opposite, which is divide. So I'm going to divide both sides by r. Both sides by r. That crosses out. Now look at the left side. Do d and r combine? No, because one's distance and one's rate, and you can't combine those. Okay, so on the left side, I have d over r, and on the right side, t is now by itself. So I'm going to put equals t. Is t all by itself now? It sure is. So all I'm going to do now is just simply rewrite it like that. Oh my gosh. Oh, the lag on this computer. That's it. I'm done. So if you're looking at these problems and you're freaking out, you're like, well, I can't do math, Mr. Parrish. It's all letters, and letters is bad. Letters is scary. Just pretend that the letters are numbers, and if they're different letters, then you can't combine them. That's all. That's it. It's easy. Easy peasy, lemon squeezy. Shall we do another? And I sure would love to see somebody with bravery and strength and confidence to tell me what to do here, what you think should be done here, whether that's unmuting themselves or just typing it in. I have to get r all by itself. Not r, I'm sorry, the red variable all by itself, so I have to get c all by itself. Is c all by itself? No. First things first, it's negative. And second thing, there's an r there. I have an r just floating around. I want to get rid of that r that's just floating around. How do I get rid of an r that's just floating around? Like I'm on my own today. Did someone say subtract r from both sides? Well, that's correct. You subtract r from both sides. So I'm going to do that. See how r is just r? Movies you're not allowed to see. I am going to get rid of r by subtracting r from both sides. I'm going to subtract r from both sides, and then that's now gone. R, take away that r, is now gone. On the left side, I have negative c. So I'm going to be creative with my colors. Negative c equals p minus r. Is c all by itself now? No, because there's a negative there. Now let's use some common sense. I know that's a -1, and I could divide -1 from both sides, but negative means opposite. So let's just think of it this way. I have negative c. If negative c equals positive p, then positive c equals negative p. And if negative c equals negative r, then positive c equals positive r. All I did was flip the signs. That's all I did. If I have negative c and I want positive c, flip everything. Flip it. Is c all by itself now? Sure is. Problem 3. I have to solve for the red variable. Or if you're colorblind, I have to solve for the gray variable. Is m all by itself? No. What's in the way? C squared. How do I get rid of a c squared that's being multiplied to m? Well, let's backtrack a little bit. Let's rewind a little bit. In problem 1, I had r times t, and the way I got rid of r was I divided it because it was r times t. Well, now here I am, and I have m times c squared. I have to get rid of times c squared. How do I get rid of times c squared, I do the opposite, which is divide c squared. I don't want to use red. Divide c squared. Divide c squared. C squared over c squared crosses out. On the left, I have E over c squared. On the right, I have m all by itself. I hate the way that looks because I want my variable on the left, so I'm just going to flip everything. M equals E over c squared. That is my answer. So we're literally just getting rid of stuff the way we normally would. And like I said in the last problem, since these letters are not the same, and since they're not numbers, if they're different things, then you're not allowed to combine them. Just pretend that they're numbers, and if they're different, you can't combine them. It's okay to be different. 2 Chainz based his entire career off of that. That's 2 Chainz. All right, I have problem 4 now. And I'm supposed to get V all by itself. So let's take a look at what I have in front of me. Is V all by itself? Let's look at the 2 things that are in the way. The 2 things that are in the way are that 3 right there and that H right there. Okay? Let's get rid of the H first because it's just easier looking if I got rid of the H first. How do I get rid of H? What is H currently doing to V that makes it in the way? Well, H is being divided from V. If I want to get rid of H that's being divided by V, I'm going to do the opposite of divided by and multiply H to both sides. Multiply H to both sides. Okay? What that looks like is that crosses out. And on the left, I have H, B. And now that the H's are gone, it equals 3. And V is still there. Is V all by itself yet? No. What's in the way? 3. What's 3 doing to V? Multiplying. How do I get rid of something that's multiplied? Divide. So I'm going to divide both sides by 3. Divide both sides by 3. And what I have is I have HB over 3 equals V. And now V is all by itself. Now V is all by itself. But you know what I'm going to say, those of you who are with me, he doesn't like V on the right. He likes it on the left. So let's just flip it. Let's just flip it real good. V equals HB over 3. And that's it. That's it. That's the volume of a cone, kids. You'll learn about that in chapter 8, maybe 7. Problem 5. Is A all by itself? No. What's in the way? Plus B. Anything else? Plus C. So I have to get rid of both of them. So let's just take our sweet old time and get rid of both of them separately. Let's get rid of B, because it's the alphabet. Minus B from both sides. On the left, I have P minus B. That's supposed to be a B. And then it's going to equal A. And then what do I have left over? Plus C. Now, even though I tried to make it red and it didn't end up red, that's fine. I still have to get A all by itself. A is not all by itself. What's in the way? Plus C is in the way. How do I get rid of it? The opposite of plus C, which is minus C. Plus C, where am I? Calculus class? 3 of you get that. So I have P minus B minus the ugliest C I've ever made in my entire life equals A. Is A all by itself now? Sure is. What do I hate about this problem? A is on the right. So let's switch it and put A on the left and have that equal P minus B minus C. And now A is all by itself. And you did it. I'm sure all of you did it ahead of time, and you just did it ahead of time. You all got it right. Is V all by itself? No. It's actually on the bottom. I don't like that. I mean, it's okay to start at the bottom. Drake made a career out of that because he started from the... I want to move it to the top. How do I move V from the bottom to the top? Well, simple. V is on the bottom. It's being divided. So the opposite of being divided is multiply to both sides. Cross you out. I now have VD on the left equals M. Now, what am I supposed to solve for? V. Is V all by itself? No. What's in the way? D is in the way. It's being multiplied to V. How do I get rid of something that's being multiplied? You divide it. So I'm going to divide both sides by D, divide both sides by D, cross you out, and in the end, I have V equals M over D, and that's it. You should be looking at these and saying, well, that's not that bad. These aren't that bad at all. Like he said, all I'm doing is just trying to get the red thing all by itself, and I'm doing the opposite of other stuff to get rid of it. That's it. Does it get worse? Does it get harder? I guess we'll find out. And the answer is yes. So now I have to get Y all by itself. This is where it's going to be a little new for people. Okay? It's going to be a little new for people, and it's okay. Don't freak out. I'm going to be here with you before I even do this problem. Okay? Can I add a slide? What does this button do? Adding new whiteboard page to this lesson. All right. Boom. I want you to pretend that we have a class of 10 gals and 8 dudes. And I wanted you to break up into multiple sections. Okay? I wanted to divide this entire group by multiple sections. Well, that's what it might look like this. I'm going to divide everybody by 2. When I divide everybody by 2, my group of 10 gals and 8 dudes is now 5 gals and 4 dudes. Why did I put D there? Because I said dudes. I meant to say B for boys. Now, that's weird. I have 1, 2 on the bottom. I divided an entire thing by 2, but in the end, I divided everything by 2. So I'm not going to write it out like that ever again. Ever again. Instead of writing out this big line and dividing an entire group by 2, what I'm going to do instead is I'm going to divide each chunk by 2. So one more time. Instead of drawing a big line and dividing an entire group by 2, I'm going to divide each chunk by 2. Divide everything by 2 means literally divide everything by 2. So my 10 girls and 8 boys is now 5 girls and 4 boys because I just divide everything by 2. Why does that matter here? You'll see in a second. Is y all by itself? No. What's in the way? 2. How is 2 in the way? It's being multiplied by. So how do I get rid of it? I divide both sides by 2. I divide the left side by 2, and I divide the right side by 2. But instead of drawing a big line and then a little 2 underneath it, I'm just going to divide everything by 2. Divide everything by 2. If you divide both sides by a number, you divide everything by that number. Everything. And this crosses out. Boop. And y is now all alone by itself. Poor y. And that's going to equal 6 over 2. 6 divided by 2, 3. Minus, can I do 5 over 2? No, I know it's 2.5. I'm not a dummy. But I do like fractions. So I'm going to leave it as a fraction. The directions were solve the equation for y. I had an x floating around. So what? Just pretend that x is just another number, but it's not really a number. Is y all by itself now? Is y all alone on the left now? So am I done? So I'm going to circle it. Or in this case, put a box around it. Not so bad. Not so bad at all. Oh, this is where it gets a little worse. So let's watch this video from a guy with a dazzling voice, and let's see if we can understand a little bit of what he's talking about. Look at the original problem there. The directions are going to be solved for y. Is y all by itself? No. I have a -3 in the way, and I have a 7x in the way. I have all this stuff in the way. How do I get rid of it? Watch and see. Watch and learn.
Solve for y. In order to get y all by itself, you need to get rid of this -3. You need to get rid of that 7x that's floating around. Always get rid of the thing that's floating around first. So since this is a positive 7x, we're going to subtract 7x from both sides, like so. Cross out the 7x. That leaves us with -3y equals, now these two don't combine because the -6 doesn't have an x, but the -7x does. So we're going to write out -7x minus 6 because they're both negative. Y is still not all by itself. You have to divide everything by -3. And when you do that, negative over a negative is a positive 7/3 x. Negative over a negative is a positive 2. And that's it.
All right, so according to the painfully handsome fella in the video, okay, I had y not even close to being all by itself. But if I want to get y all by itself, all I have to do is just take the thing that's not attached to y, the thing that's floating around, and just get rid of it. And then if y has something attached to it, I divide it from both sides. It's no different than if I had a two-step equation. So let's take a look at what we have. Okay, let's take a look at what we have. Is y all by itself? There's my y. No. I have 4x in the way, and I have -4 being multiplied to y. So y is not even close to being all by itself. Not even close. Okay. I have a 4x floating around, and I have a -4 attached to y. Always, 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 always get rid of the thing that's floating around first. The thing that's not attached to y, get rid of it first. The thing that's not attached to y is 4x. Get rid of that first. It's a 4x. How do I remove a 4x? The opposite of 4x, and the opposite means negative or minus, so the opposite of 4x is -4x, and I'm going to put that on both sides. -4x minus 4x. Cross that out. What drops down on the left is negative 4y. And on the right side, I have 1 and negative 4x. Do 1 and negative 4x combine? No, because one of them has a variable and the other one doesn't. So I have a negative 4x. I'm going to write that first, negative 4x. And I have a positive 1. So I'm going to write it out that way. I like my x's first. Not in real life, though. Well, do I have y all by itself? No. What's in the way? Negative 4. How is negative 4 in the way? It's being multiplied. So what do? Divide negative 4 from both sides, which means I divide negative 4 from everything. Everything. Look what I just did. See how I had negative 4 over negative 4 and it just crossed out? Look what I have on the right side. Negative 4 over negative 4. Cross it out. Same rules apply. Now on the left, I have y, which means y is all by itself now. This crossed out, so I could just bring down x. And what's 1 divided by negative 4? Positive divided by negative is a negative. And 1 over 4 is just a fraction 1 over 4. Leave it that way. So just like the video, I moved that guy and I divided that guy. I moved that guy and I divided that guy. I moved that guy and I divided that guy. Let's see if we have to do it again. Look, we do. Is y all by itself? No. So I have to move that guy and then I have to divide that guy. Okay, so let's erase it. So I have a 4x floating around. I have to move that guy by doing the opposite of 4x that's floating around. And the opposite of 4x is negative or minus 4x. Minus 4x. Cross you out, you're gone. So what I'm going to write on the left side is, do 6 and negative 4x combine? No, because one has a variable and the other one doesn't. So I'm going to always write out the thing with the x first, negative 4x. 6 is positive, so plus 6, and that equals 9y. Is y all by itself? No. What's in the way? 9. How do I get rid of a multiply by 9? Do the opposite, which is divide. Divide 9 from everything. Negative 4 over 9. That's a fraction. Does it simplify? Negative 4 over 9? No. So I have negative 4 over 9. X comes along for the ride. 6 over 9. Does that simplify? Yup. Divide them both by 3. So plus 2 over 3. Now that 9's gone, that equals y. Is y all by itself? Yes, but it's in the wrong way. So instead of saying blah, blah, blah equals y, I'm going to say y equals blah, blah, blah. I don't say blah, blah, blah. Hotel Transylvania. Hate that movie. Is y all by itself now? Sure is. Sure is. And we got 8 minutes to go. Problem 10. Is y all by itself? No. What's in the way? 6x is floating around and 3 is multiplied to y. Get rid of the guy that's floating around first. The opposite of 6x is negative 6x. Negative 6x. Cross you out. Look at the left side. On the left side, I have 12 and negative 6x. Do they combine? No, because one has a variable and the other one doesn't. So I'm going to write out negative 6x plus 12. Why plus 12? Because it's a positive 12. On the right side, the 6x is gone, and I have 3y. Is y all by itself? No. What's in the way? 3 is being multiplied to y. So what's the opposite of 3 being multiplied to y? Divide 3 from everything. Cross you out. It's a fly. Can you simplify negative 2 divided by 3? Sure. Can you simplify Can you simplify 12 divided by 3? Sure. Is y all by itself? Sure. Is it in the right direction? No. So flip it. Y equals negative 2x plus 4. Fun, huh? So we have an equation, k equals c plus 273.15, gross. K is for Kelvin, C is for Celsius. Convert 200 degrees Celsius to Kelvin. Well, that's easy. Part A is just take 200 degrees, K equals 200 degrees Celsius, plug that in for C, plus Kelvin, or not plus Kelvin, plus 273, add them, and I get K equals 473.15. Easy peasy. That wasn't bad. That wasn't bad at all. A was just fine. Solve the formula for C. That's where it gets tricky. That's where they're trying to get you. So I'm going to rewrite the original equation down there. K equals C plus 273.15. What I need to do is I need to solve for C. Is C all by itself? No. What's in the way? That pesky 200 number. So I have to get rid of that 200 number that's just floating around. How do I get rid of the number that's just floating around? Subtract it. Do the opposite. Minus 273.15 from both sides. Minus 273.15 from both sides. Look at the left. I have K and I have minus 200. Blah, blah, blah. Do those numbers combine? No, because one's a K and one is a number. So I'm going to write out K minus 273.15 equals C. Did I solve the formula for C? I sure did, but it's in the wrong way again. So I'm going to switch it. C equals K minus 273.15. That's my answer to B. And C has me taking that formula that I just wrote out, which I'm going to rewrite again. C equals K minus 273.15. And I'm going to turn K into 300. Let me do that. Let me just erase right there and turn it into 300. Like the Spartans. 300 minus 26.85. I think that's it. I think that's it. Looks about right to me. So this section was tricky. It really was. And it might be worth your while to do this again. Okay, just to watch this video again. I'm going to post this on YouTube later. And it might be worth your while to do it again. I mean, if you look at the problem down there where it says find the error, solve for y, I see it immediately. If you get rid of 2x, what's still lingering? A minus sign. What did they not write down? A minus sign. So little tiny things are what's going to get us each and every time. So that's the end of that lesson.